Hey, how's it going? It's Andrew Nakis here. I'm coming in hot from my computer. This is a 360 video screen tutorial. Episode 1 of building Google VR's Daydream Labs. And today we're going to be going in and trying to build the Google Daydream Labs drum key example that they demoed from scratch. We're going to be using Unity. This is kind of the Unity project. My main screen is just a standard device display, or standard screen display, and then the other windows are Mono Develop and the game and scene view for Unity. So let's just for reference, see what we're going to be building today. And they handedly made a YouTube video about it for reference. And it's a pretty simple scene. There's text, there's keys that are volumetric that you hit with your SteamVR setup. So if we watch that again, you can see the keys kind of move up, move when they get hit, and also illuminate when they get hit, as well as the size, the relative size compared to like the controller, which is like roughly the trackpad of the SteamVR controller. The ball's probably roughly about a half of that size, and the key's about roughly that half of that size. So we kind of have the basis of it. And right now, once I delete this script, we are in just a super fresh Unity project. I have created a couple art assets that do have the buttons effect, give the buttons the look that they need. So I'll make sure to include those. Kind of the idea is I'll be doing like a full GitHub around a project around it. So if you don't want to, you don't have to watch me code and do everything, and you can kind of just jump right into the juicy fun stuff. So the first thing we're going to do is import the SteamVR plugin, which is kind of going to be our bread and butter, the environment that we're building in. And you know, honestly, like, I mainly am most familiar with like the Google VR cardboard environment, and it's fascinating because the SteamVR environment doesn't really have any documentation. They just have example scripts, where the Google VR stuff has a lot more documentation around it, and I find that's a lot simpler to work with, where kind of this setup is a little bit more archaic to me. And it gives you all these like suggestions to do. I think most of them are good. And so now that we have the scene set up how we want it to, we can go in and drag in the SteamVR prefab room scale environment. And so this kind of is everything we need to get started. We can delete this camera and make sure to save the scene. That's always something I forget, and then Unity crashes and I lose all my work. But kind of the basis of how we're going to start is just going to make sure it works, and then we're just kind of going to jump in and start building out like the controller selectors, and then also the so in the blue screen there's not much depth right now, so we can't actually track this stuff, and this controller doesn't seem to be tracking, but Looks like we're in the correct environment. First thing we're going to do is go into lighting and switch it from color to skybox. So now, in theory, and also adjust that in the camera. And then, in theory, we'll have a skybox. I'm going to play, which doesn't seem to be working right now. Which is weird, because I could have sworn it was like default. Just loaded up on the skybox. Oh, that's why. It's because we didn't have a skybox loaded. Okay, so now we're in a default skybox. If we hit play, we're looking, and there's clear down and up, and we have both controllers. So we are officially ready to build out this environment. So one interesting thing about the development, just commentary about Vive development, is that you can't actually see what you're building. So if we go as in you can't see the controllers when they're there. They just start at 0, 0, and you just kind of have to guess. And so it is kind of feels like a big guessing game, especially with the scale of everything. So you have to make everything super tiny. We're going to rotate it 90 degrees. This is kind of like the stem of the selecting controller. So let's go even smaller. And then if we attach this to one of the controllers, in theory, if we look at this stuff, yeah, we have now the stem attaching out of our controller. So put the cam down. Okay, so let's make this a little bit longer. And then we should probably move it up as well, move it forward. Half of the length, so it ends at the tip. Yeah, it's still kind of sticking out. This also could probably be a little even tinier. Let's half it. And a lot of this stuff is just kind of playing around with the scale of this stuff, and so kind of making sure everything works how it should be. Cool. So that looks pretty good. It might be a little bit too long. Let's just double check. Just roughly, probably could go a little bit shorter on that. The cool thing is we can kind of look at this at runtime, but then we just need to make sure to edit those values after. And now, okay, it's looking, let's hold it at the same angle as the Daydream controller, Daydream video. Maybe a little bit shorter. Let's try 0.25. And I'm adjusting both the scale and the position, so it kind of goes right at the end of the controller. That's looking pretty good. So now we just want to make that end piece. So I'm going to create a sphere. And it's interesting too, they kind of have a light coming out of it, out of their sphere. So we're going to make the light a sphere material that we can then drag on the sphere that we created. And if we go in, we can actually adjust the emission of it. So now it's this bright thing. Well, let's just make it really tiny. put it at the end, attach it to the cylinder so it's a parent. Well, let's make it a parent of the controller just so it'll be a little easier to call the controller later on. Cool. And so looking at it, if we compare it to, I don't know why the controller is so black. I think there's like no texture. Everything's just super dark. And I don't think this is the most ideal for just seeing stuff. But if we do go in, the ambient, kind of adjust the ambient color of the environment so it is more flat or more bright, so things just aren't dark because there's no light. We probably shouldn't do that. We should actually probably just put like a normal light in. So let's go ahead and do that. Usually it comes with a directional light. That was weird how it didn't have one. Or maybe I deleted it. I don't know. Cool. And so now in the game view, yeah, we got controllers that we can actually see and read because they have light. And our rod needs to be black, so let's create a cylinder material for that. With black. Call it stem. Cool. And so it looks like, I mean, the sphere might be a little bit too big, but we kind of have the basic volumetric typing thing, and it's pretty fun to just swing around. Drumstick, I guess it could be called. So once we make the sphere a little bit smaller, let's just try like having it. Get the perspective and then switch to get the reference. I mean, that looks about right. I don't think, I mean, technically if it's smaller you're just going to get a little bit more precision when you actually do type with it. So let's just leave it at that right for now. Cool. And so now that we have this kind of environment set up, one thing the next thing to do would be to start making the keys and having one key detect collision. It's interesting. Okay, so we're going to use the play environment to kind of prototype out the space, and instead of like having to like reach around, we should just build a key kind of. I'm in the corner of my room scale environment, so I'm just going to build this like button, put a button in kind of right at these coordinates. So if I unpause, I should be at the similar scene view. Let's create a cylinder right there. Obviously make it a lot tinier. A lot less tall. Cool. And so now, where we are, yeah, there's a cylinder. It's kind of like right over here-ish, so it's still a little bit out of the way. Let's just move it more center. Cool. It's kind of hard to see. I think this is a good time to like load in the textures that I have up, that I have loaded, just that I've made earlier. And so they're in assets, and then I'm also going to load in I found like a button sound effect that's just kind of, you know, it's very basic. I think it sounds good. It was made on, I got it on freesound.org, and it's simple. It's not exactly like the sound that they had, but I think it should work. And so if we actually, there's an interesting glitch that I found with when I was putting in like the material for the keys, and that's, you get this kind of side, because the cylinder's not mapped properly. I mean, ideally I should make a new cylinder in Blender and map the sphere, the sides of it, so it correctly displays the right portion of the texture. But in Unity, by default, it just pastes each side of the sphere on each side of the actual game shape that you're prototyping with. So to get around this in like a very hacky way, we're just gonna copy another version of the cylinder, make it a little bit shorter, but then also make it slightly fatter on either side. And then like there's actually two textures that we've imported, and so we're just gonna do like a kind of a side texture loaded into it. And I mean, this is super hacky, and like you can clearly see there's like a small indent that we can try to adjust, but it's never going to be perfect because one of them's like the wrong color. And so like if I was serious about this stuff and like actually making production quality stuff besides just hacking around with tutorials, I would probably go in and make and map a cylinder in Blender with the right UV texture, but that's neither here nor there. And it's a little bit hackier. You make the cylinder a parent object, and now you can move it all as one piece. And so let's see. Okay, cool. It's in the environment. It's still kind of a little far away. I'm like kind of fingering the computer. So I'm just going to move it a little bit closer. It should be like right where my keyboard is. So I mean, like typing. Yeah, I think that's pretty good. I'll just move it a little bit down. And now I can start in actually setting up the sphere to detect the collision of the button and really creating the button effect. So the first thing we're going to do is make a rigid body that doesn't use gravity and is completely frozen. And this rigid body is just there to detect collisions of the object. Now we're going to make our first script that we're going to put on the sphere to see if we can detect a game object. Okay, C# script, let's call it collision detect. And then we're going to drag it on the sphere. Why is this not going in? I feel like the Windows is kind of messing me up right now with Windows is messing me up where I can't actually load in the script because it doesn't let me drag it into down low because I'm full screen in Unity right now. It's like not giving me the plus script thing. So if I make this a little smaller, it's hard because with this 360 environment I like can't adjust the window layouts that well. or else it just super freaks out. But I can like adjust the size and stuff. I'm kind of just, this is like such a weird problem to have. I guess we could just add it directly. That should work. So just add the script manually into it. We're going to add the public void on collision enter collision and so this is, we're putting a debug thing to just find if it collides with an object, and then just tell us what the object's called. And it's going to collide with the stem that we've created because it's just touching it by default. But in theory, we should also be able to see in the console that it also touches the button, because that has a trigger on it. So it touched the cylinder, and if we move it around, I guess yeah, there we go. It's touching cylinder 1. So it just registered that it's touching more cylinders, even though there are some cylinders that we really just wanted to ignore those collisions. And so to do that, I guess we want it to touch the top, and we don't want to touch the bottom. We're going to make a new layer, and layers are kind of like tags in Unity. They're a way to organize things. But layers have this ability to work with the physics engine. So you can actually go in, create a layer, assign the cylinders that you don't want it to touch, which in this case it's the stem on the game object, and then also the secondary hacky cylinder side that we used. And so once that's in, you can go into project settings, physics, I believe, and then you can see there's a default layer and wall layer. These are the layer collision matrices, and if you just uncheck that, now all collisions between default and wall will be ignored, and so we don't get a debug log instantly when it's touching the button. But if we hover over the button, we see every single time I tap this button, it sends me a little message that it just tapped the trigger. So cool. So now we got that. That's great. And so now I guess we kind of have the basis of a button working. We should probably go in, and like this is an interesting time because there's a couple different things we can go about it. We can just start building the keyboards. We can start doing a lot of these button effects that happen when you touch the button. Or I think what we should do, which is probably the most kind of crucial, is define the system that happens when you touch the button. It then displays text that button, like each button gets assigned to text, and then it sends it to like a text canvas object that then displays the updated text, the keystroke. And like that's kind of the essential. Once we have that, we kind of have the core of the project done. And there's kind of a bunch of different ways you can do it. You can kind of go in and assign tags. So I could literally go in and assign a tag for each letter, and then it says like on the collision enter, the game object equals space or equals W, and if the tag equals W, then it updates the string with a W. And honestly, so there's the other option is to use something like layers, which are made for physics, so that's not ideal. Or the other thought is I can just name it. I can just name it Q, which is like the first letter that I think about on keyboards. And so when I rename it that, now I can say, okay, when the trigger touches it, it gives me a queue debug log message. And I don't know if this is the best way. I think tags might be a little bit better just from like a naming project organization perspective. But I think either way could really work. So let's just do it with names. I think I find it a little bit easier to go through and name everything than like create a tag and then assign a tag to everything. Even though like the hardest part about this project is for sure going to be actually setting up the keyboard. Cool. So now that we got that going on, let's actually create a label for the object. And so how we're going to do that is we're going to actually assign a canvas to world space that is kind of, we'll have an individual canvas for every label on this text. And one interesting thing that I've found is Unity used to have, like before 4.6, they used to have so they have their whole UI thing, but then you can go in a 3D object and create a 3D text. And I was all excited because I was like, oh, I guess you could still do it. And so now the question is this 3D text renderer more efficient than a bunch of world space canvases? And that's a good question, because the thought is that when I was playing around with 3D text on mobile pre 4.6 days, it was so inefficient, and the world space text is like way more efficient, but that becomes more of a question mark when you have like 26 or 27 or 28 world space canvases that each have a canvas script and all this canvas stuff on them. But that being said, like everyone that has a Vive has like a $600 gaming setup or better, so it's like kind of this thing where we're kind of drinking out of a fire hose, so I'm not sure if it's a big deal. But we need to make this really tiny. So let's go in, put the rotations at the correct thing, and make it an orders of magnitude smaller to fit, to make sure it's the right size. I think it's going to be too tiny. Ooh, actually that looks pretty good. Because the thought is like, the other way to do the keyboard stuff is to do it like all on one canvas. And honestly, like the other option, just from a layout perspective, is to do the entire keyboard stuff in world canvas. The problem with that is, and like I think it could work, and honestly it'd be maybe even a little bit more efficient. Just from a tapping perspective, you could certainly do it, but from like a material sense, and from just because these are like 3D volumetric keys, it makes sense to have them as a game object, because you can't do like scale increases on a Z plan that well, like because canvases are by default just 2D. But I think it could totally work, and like from an efficiency standpoint, it'd probably be way more efficient for like an actual game if you were to put this input system into the actual game. And so now I just need to make the actual text for it. 300. It's weird how I wish they just defaulted to overflow. The amount every single time I always flip that so you can work with text really easy. And yeah, that looks like it's our key. It looks like a good label. It's probably not the best font choice, Arial, but it will get the job done. Just flip it around. So now, go up to the Q. It's labeled the right way. It's not center, but we have the button. And like, to make all the other buttons, we were literally just going to copy this button. So we got that kind of squared away. And I guess the next really is the fun stuff, because now we have the game object. Every time you hit it, it says Q and it's labeled correctly. So let's actually go in and make the world space canvas that we're going to actually like type on. That will display the text. So I go in, we're going to make it really tiny again. It's fascinating like how much smaller thing you need to make everything, like if you're working in VR, because just the scale of your one-to-one movement. Every unit in Unity is like a meter, so to get things to the correct size they need to be really tiny. And so I've been playing around with the new UI in Unity 5 a lot, and the one thing that I can never, and like I love it, it's so much more intuitive than the previous system, but the one thing that I can never understand is text input field. I mean, and I've totally gotten working before, but it's so much more archaic than like standard text is. It has nice like input things for touch stuff, but generally like when I was prototyping mobile with touch, I would just use the legacy GUI interface, mainly just because it worked a lot better, I found, on mobile. But it could be different for computer stuff, which I haven't really done too much publishing of apps that require input on PCs, so I wouldn't really know. But I'm kind of getting into this stuff because this world space canvas that we set up that has a computer, we're going to use just a text field, and it's like kind of very hacky, but literally all we're going to do is update the text. So when you hit a keyboard, it just updates the text. And again, this is like not the best way, like from a production standpoint, totally wouldn't do it like this, but I think just from this hacky nature of this entire project, totally kosher. Let's move to overflow and make it blank. And so now our big kind of idea is, okay, when an object collides with these buttons, which I'll make the buttons lower, when it collides with the buttons, well, that's weird. When you turn on the controller, it's not there, the controller doesn't appear. When it collides, it needs to update that text to actually say Q one time. And so the interesting idea is we need to make a new script, because we have these collision detect things on the sphere, but there's going to be two of them in the game. And so when those detected just a collision, we then need to go in and say update like a key manager script. And this key manager script will just live on like just a random manager game object. But kind of the idea is the collision of the sphere will trigger a bool or trigger a class or method function that then turns on the key manager script and then updates that text that we saw. So using Unity Engine UI, public text, key text. So this is the text that we actually need to declare when we put this on a game object. Let's just create an empty game object and call it key management. And so now this text, declare it. And so, okay, now we need to make these two scripts talk to each other. So when the collision enter happens, it needs to flip something here that then updates this text. And you know, I think there's a bunch of different ways to do it, but one of the simplest ways is just to do, and like again, this goes into the whole hacky nature of the whole project, where ideally you do it with something that like couldn't break, stuff. Because like, so the idea is to use a string. So when the collision detect happens, it updates a string that then gets added and called, updates like a string and then updates and like makes a static bool that's like has hit. So it's like when we hit these objects, it turns on a bool and then also turns on the string that tells it what it is. So if has hit equals true, then the text key tag dot text plus equals okay. So the basis is if we hit it on a collision enter, key manager dot has hit equals true, key manager has hit by key num equals colon dot. So okay, so yeah, basis, when it hits, it turns this bool and assigns a string that's the name of the game object key that we had, and then in update, if that has hit bool equals true, checks all the time, and it updates that key text, that text that we assigned with the UI, to the string that we assigned in collision detect, and then it turns the has hit false, so it doesn't give us like a million updates to that string. Let's see if that works. Good, didn't get any errors, so that's like a good start. Okay, Q, 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 Q. Yeah, I mean, it seems to be working kind of well. And like we have the basis of a keyboard or a button that inputs one key, and if we copied it 25 other times, it would be a full keyboard. You can kind of go in and go nuts with, and like it doesn't make new lines, so you can kind of get that really simply in the key manager. Line care num, and so okay, so then every single time it adds a new key, line care num goes up, and then if line care num is greater or equal to, let's do some big number like 30, then key text plus equals new line. Okay, let's see if that works. Keys. Whoa. Okay. So yeah, so I mean it worked, and then it was equal to that Q for a long time, so then it just made like a million new lines, it looks like. So one thing that we're gonna need to do is once the new line happens, equals 0. Just assign it back to 0. Cool. And like, yeah, we could probably increase that number a little bit, or just make the font bigger. The font's really tiny for some reason. Let's just do that. Bigger font is better. This might be too big. Yep, too big. By 5 letters, it looks like. Okay, so let's just move this a little bit over so it starts right there, and then make it equal to 25. So now, in theory, fingers crossed, we should be good. And I guess kind of the next thing that we could think about is you kind of have text input, like, and you would think if we copy this to every single letter, we could type strings. I think the next step is would be to add in the material effects that happen. So we make that sound effect, and then we make it bigger. And actually, I haven't. So when I was playing around with like just hacking this earlier, I tried to get the light stuff to happen on these keys. Let's just bring it up again just for reference so we know what we're building. Like the keys flash, and like I was trying to do that. You can do that like by putting a manual light that just flashes on and off when you hit a key, like above each key. And like we could certainly do that, but it doesn't look like they do it like that because the entire key kind of lights up. Let's see if I could. Or maybe not. Maybe it is just. Looks like it is like kind of like a point. A point system. Like, because before I was going to use I was trying to get a mission to make it work, and I was failing miserably. Like I couldn't get the material to update the texture. But I think now I'm actually kind of optimistic that we can get the light to a point light to turn on when we hit the key. So let's just try. Let's try some of this stuff. Okay. So I think the first thing that we're going to need to do, that we should do, is just have it play the sound. Just because that's the easiest. Just putting in headphones so you can actually hear it. I unchecked play on awake, so it didn't play on awake. It's weird how that defaults. It always gets me. So I just heard it. Okay, so now I think we're gonna do. I guess we could put it on the key, and then we'd have to say on the collision when it collides, actually turn on the sound on that specific key. I think the simpler way, and they're both kind of simple, is we can just put it on the sphere, if we can ever add it to the sphere. Gotta love Unity. There we go. It's like so low. Here, let's make sure to save the project, so if we lost it, I'm just getting all scared with it being all funky, recording like a 4K stream while I'm doing Vive development. It's probably not the best for my computer. Okay, so it's on the sphere. Oh my god, I can't spell. Okay. Ooh, so it plays on awake, and then every time you hit it, okay, so here's just an interesting thought. It's like right now, when I'm over the key, I can literally just like hover, because it's anytime it goes on trigger enter or on collision enter, it plays the key. I guess that kind of works. It's like the idea is we don't want to be able to have people just like hit a million keys at once, but we can put it like a kind of a big trigger in over the entire keyboard later that turns all this stuff off. When we actually select a key. Okay, so it's playing the audio source. And now we kind of need to do stuff to the actual key when we hit it. So we need to make a script on the Q script that turns on that light that we are going to make, and then also turns on the scaling. So let's call it material hit. Assign it to the Q. Okay. And I'm just thinking what would be the most effective way, because we can't have like to communicate to the script. You can't have like a static bool because it's not like a singleton. So because there's going to be a million of these keys, or 28 or something of these keys. So let's create a bool called just hit. And we're going to go in, and when it actually collides with the object, we're going to go in and go to call game object and actually just turn on that bool. And so here's like an interesting thing, because right now it's just on collision enter. So if it collides with anything that's available, like if it collided with that canvas or like another controller, it would like give us false positives, and the non-key scripts don't have these material hit scripts on them, so we get like a bunch of errors, which wouldn't be good. So I think a good thing to do right now is we should just create I need to save the script to make it work. But we should just create like a tag over the key object. Also turn play on wake off. Tag over the key object that just makes it so it's a key. And so now so now if it's an actual key object or key tag, it will do all that stuff, and if not, it doesn't give us like these crazy false positives and like a million errors. Cool. So we got it, and it looks like just hit would hit true. And what just hit's gonna do is like turn on what that bool. Turning on that bool is kind of the thing that's going to trigger the all the material stuff and the light hit happening. Okay, so I like kind of the idea is we need to raise the local scale up and then lower it down. So we're going to need some floats to kind of like max scale. So then if it hits this max scale, we then starts going down. We also need a float for just the range, like the amount that it's going up. And I think we need a bool that's like, once it goes up and hits this max scale, it then has fully increased. So you just need the increased bool. And then I'm always like, do we need a decreasing bool? That's like, this is decreasing, but if the increased bool equals true, then it should just decrease until it hits the other float we need is the current scale. The idea is a lot of this stuff is written just so if we change the size of all the keys, it will still work. So let's try to assign stuff. Cur. What is the current scale? So it's 0.1. So the max scale, let's just make the max scale 0.15. Cool. Okay, so when it equals true, the transform. Oh yeah. If increased equals false, totally did not spell increased right. Increased equals false. Plus equals range on the x, and then range. We don't want to scale the y just because it's like it doesn't need to get bigger. Well, let's just check. Because it looks like it gets higher. Also, just kind of looks like it gets wider. I don't know. I don't think it matters. Either way, let's just make it 0. Just keep it simple. Because I feel like it would, if it was going up, it would like give you false positive triggers potentially, where you like accidentally trigger it twice because you lift it up, but it still came up and hit you. Okay, so if increased equals false. So now another bool, if transform.local scale dot x is greater than max. Okay, so if the scale is greater than the max scale, then make it, say it's already increased, and then if it's already increased, there's only one thing to do, and that's make it decrease. Cool. So now that it's increased, kind of just can take this same thing and just minus equals. Cool. And then if increased equals true, so it's already got to the max, and transform.local scale is smaller or equal to the transform.local scale of x is smaller or equal to the smallest, the current scale, the baseline scale, then we need to reset everything, which is going to be hard, or because, well, we want increased to equal false right there. So I think we do need a decreasing bool just to create that separation. Because so increase equals true, and then it's also decreasing equals true. because if we call increase, if we reset increase to equal false, and then also try to do just hit to equal false, then like increase would equal false, and then it wouldn't cause just hit to equal false. Or if we do just hit equals false first, or increasing equals, it would just cancel each other out. So we're going to make this equal to true. Oh, yeah, how can we do this? Let me think about it for a second. Yeah. I guess just hit will equal false when it's outside of. So once it finishes this stuff, yeah, that makes sense. Once it finishes everything and goes through all this stuff, then just hit equals false and it cancels out. And then, so I guess we don't really need decreasing. But let's just keep it in because it's easier that way. Alright, fingers crossed. Any errors? Dun dun dun. Moment of truth. Ooh, cool. So the real moment of truth is if we actually hit the thing, what will happen? Controller detect. There we go. Ooh, looks like it got bigger. It didn't get smaller though. Alright, yeah, it's at. Or did it? Oh, it's because it's not even on. Or it is. Yeah, let's see if it got bigger. Yeah, so it's going up, and now it's going down. It's not. Oh, it's probably because just hit. That doesn't work. Just putting it at the end, just because the way. I guess, so it doesn't need to be declared false. It can be declared false at the beginning, right? Or does that? Let's see if that works. Because then we'll just decrease. We'll just run it and yeah, every frame it can't do that either. Another thought is, well, what would it really break this? Okay, there we go. So yeah, it gets bigger and then it gets smaller. It's like a normal tap. So cool. So now we have everything except for the light. Which is going to be an interesting one because it's going to have to be a child object to this. But the child object can be declared in in a public variable. So it shouldn't be that big of a deal. Okay, we're going to make this really tiny. I always forget which, there's like specific lights that, it's like a point light, directional lights. I think we want a spotlight, which is not the most memory efficient from what I remember. So let's see. Oh yeah, totally. Okay, so then it's kind of like a backlight keyboard. What we need to do is I guess we don't need the range that long. Let's make it small. Cool. So the range just needs to scale up. It's weird how good the 8 is like the max. What happens if I go past that? Nothing. Okay, so 8's the max. Okay, yeah, so if I increase the range, it becomes more powerful. 2. Because what's the range that they use at the pros? Looks like it's not even getting that bright, so I think it can work where it was before. And then on material hit, and I wonder, so this is the thought, like it always just escapes me in the moment of need, but if I declare this game object a light, and then I assign, if I declare the light, and then assign the light source to it, and then I copy the entire parent object, which light is the one declared? Is it? Yeah, okay. So it is it's the local one. So cool. Okay. So I bet we could just kind of like hack into this system right here. So when it's increasing, light.get component is this not a light? Can you even do that? Can I even call in like get component light object? Yeah. It's weird how it doesn't give me any like, here's like the mono develop nice things. Oh, that's it's all written wrong. There we go. Okay. Looks like, yeah, we can call this stuff. Intensity. .2. And then decreasing equals true. It's going down, and minus equal to 0.2. Ooh, if this works, that'd be cool. Yes. Those floats. So, like, the initial way of, like, modifying, like, a shader and, like, the emission values of the shader, kind of the idea is it's just not as material as this is. So I think the light intensity is moving. It just doesn't reset fully because it's like hacked into the system. Yeah, so it goes up from 7 to 8. I guess it was at 8 before. What happens if it goes up? It's weird how it like bounces around so much. And it ends up at 2. And it goes down to 8. Okay, I think we're going to need to establish a baseline. Okay, it just needs to be like way bigger. It needs to go all the way up to 8, and right now it's coming up to like 1.5. Ooh, yeah, there's a little bit of it. Let's just increase the range. Double it. The inverse square law of lights, I knew that from film school. Just got 4 times as powerful. Ooh. You know, I don't think that's exactly kind of what they have. But it's just that it doesn't hit all of it right now. The spot angle isn't big enough. And it just reflects differently. Ooh, yeah, I think that's okay. Cool. So now, I mean, we pretty much have the sound effect. We have the light, the size increasing, and the sound. There's like one other small thing that we should do, and this actually I might. This one's kind of archaic, or not archaic, but it's just haptic feedback from the controller. Because I'm just going to go to the Daydream presentation real quick. And actually, Daydream Dreamlabs, that's what it's called. And I'm like hovering right around it, I think. Now
we're going to do a little exercise.
Maybe not.
Let's
here it is. Okay. He says it.
This is a volumetric keyboard.
Volumetric.
The buttons give visual, sound, and haptic feedback.
The haptic feedback.
This makes the keyboard feel responsive and fun to use.
Let's just replay that sound clip one more time, because that kind of goes into the So we just
call this one drum keys.
need to do haptic
This is
feedback
a volumetric keyboard.
on the
The
controller.
buttons give visual, sound, and haptic feedback to the user. This makes the keyboard feel responsive and fun to use. The feedback may seem very subtle, but it is very noticeable when it is missing. Just for kicks, we made a game out of it to see who had the highest words per minute.
Okay, yeah, so we're not going to do the words per minute stuff, but the haptic feedback, I think, is interesting how, like, it's noticeable if it's not missing, or if it's missing, it doesn't feel right. One thing that I've noticed, just critique about the Vive controllers, is like the haptic feedback could be so much stronger. But let's go in and do that. And we're going to do it in the collision detect script, just because it's the closest game object thing to the controller, so then we just don't have to write like tons of code like to find the controller. So we're going to do using VR, and this is like part of the problem, not the problem, but like one critique that I have for SteamVR is that, like, for me, going, like, I couldn't just, like, as a developer jump into this stuff and learn it. Like, I had to, like, kind of like really kind of look around to see like what are the best practices to make sure I'm doing this right. And then like I can't just like easily reference, like I'm super lazy where like I love to just go in and reference example code that's been done a bunch of times in like documentation that has like how to define a SteamVR controller. But it doesn't, like I can't just do that, like, and it's kind of frustrating, and like honestly it makes me a better programmer because that's what I'm not the best at. But it's just kind of like, oh man, I wish it was better. I wish it was easier to just go in and like whoever they like literally, I feel like everything that they do is typed so strongly and like so long. It's like, I don't know, compared to like Google Cardboard, for example. It's just there's a lot of stuff, and then like I'll go into it a little bit, not like ranting because the SteamVR system is like amazing, but like to do haptic feedback, for example, we now need to call the haptic feedback, so when it hits a key it's gonna cause this like SteamVR controller.input, and like it's like, okay, well wait, like I should have declared like a controller thing, but it just doesn't make sense because this is the only thing that we're doing on the controller, like a controller object, so I don't have to do this manually. But it's like they have these like, and I couldn't even figure out what they are. I mean, I'm sure any CS student, any CS person is just super like this. It's obvious, but they have you call the index of the controller to make sure it's the right controller, and from the tracked object that we defined up in the start script. But the tracked object dot index is not an int, so you have to cast it. It's like a uint, and so you have to cast it as an int, and then you have to type all that stuff just to get into the. And I'm sure there's like great reasons for all this stuff, and it like totally makes sense from like a layout structure perspective, but whatever. So it's like it's in milliseconds, and in theory that should be the right code. So then when the controller hits the key, it vibrates. And you guys obviously can't tell that, but I'll like confirm it. Okay, so I don't oh, I feel it now. It's like you can kind of hear it. My mic's really crappy, so you won't be able to actually hear it. But it like, it literally just taps and vibrates. It's like weird, like what happens if I made it like 10,000 milliseconds? Like you'd think I might just be doing this wrong. Like I haven't really seen too much haptic feedback example code for like long hits. Like it doesn't come in. That's strange. Like now it's not working at all. The whole thing just shuts down. What happens if I do 1,000? I don't know why I'm doing this because you guys can't even tell what I'm doing right now, but yeah, it's just this little hint of feedback, which I guess is really helpful. So let's keep that in. Okay, so now we have the key that does exactly what we needed to do. And so now is like the not fun part. Now is the part where we make the actual keyboard that like types and do like put a space bar in and everything. And so it just takes a while. Like I may just honestly, if I don't say anything interesting while I'm setting up the entire keyboard, I might just like time lapse the entire thing. But like the first thing I'm going to do is set it up is like make a keyboard, because we want to be able to move all these keys together. And like I actually wrote a script, so I like kind of hacked this project together, like roughly, like not as well as I'm doing it right now, earlier or like yesterday, and I included a script where, depending on wherever your head position was when you started out, it would automatically like kind of the keyboard would spawn in front of you. And so I may include that script, like it really well commented, in the Git section, or I will now because I've said it. But I think just keeping it like static, there's problems with that, where the keyboard doesn't or if the controller doesn't get tracked initially, the keyboard just ends up at 0, 0, 0, which is like not ideal, obviously, and then you have to like reset the keyboard to reorientate it. Cool, so this is right over the game object's right over the Q. The other thing is, like, how do we define the spacing that all these keys go in? I think really it's like 1.2 is what I found kind of works. And this is the really annoying part, because I literally just go in and make every key, which takes forever. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 keys on the initial first row. And so we have one Q, that's 0.1. What else we do? 0.1, 2. Okay. Is that good spacing? Maybe 1, 2, 5. Okay, I think that's gonna be okay. 0.25. Oh. And like, I mean, it's just like, this isn't that hard or anything. It's just kind of annoying to do this for 26 keys, and then we need to go in afterwards, after I put all these keys here, and like rename all the keys. So it just takes forever to do. So maybe what I'll do is I'm going to set up this first row, and kind of like I'm starting at 0, so like the center is oriented. And then I'll like go through how I set up like the first key, and then, or set up like the first key, and then I'll just like time lapse the rest. I think that should work, because I don't think. I mean, I don't know. I feel like it just makes sense from going into a time lapse. But let's get this in first row set up. Uh, 625. Ooh. Okay. And so the interesting thought, and I didn't even think about this with the tag stuff, but kind of right now, it's almost better if we do it by naming, because we name it Q, and then you go and you have to name the label Q, which this one's already set up as Q. And go in and name this one W. But if it was the tag stuff's really good for defining that it's a key, and so because the naming is what defines the actual letter input. I think it's almost like a better thing. Okay, so that's, I didn't hit return when I typed, and so this is the interesting glitch where, like, if you were to hit something that's not named, like the right thing, you're kind of just like, okay. So that's like a glitch that I think can be avoided, but it's just something to be aware of. Cool. So yeah, now I have this entire row of keys. I kind of just going to go through and do this for each row. But what I'll do right now, just quickly before I do that, is go in and actually, I'm going to just copy this row, or let's actually make, just for organizational sake, make a game object that's like top row, bottom row, and middle row. And kind of what I'm showing here is like, I'm gonna go in and like kind of do like a little offset on like and like, so in Daydream Labs, you can go to it, they have like an ergonomic rounded keys, and like I could do that, it just, you know, it's kind of annoying to set up, so I'm just gonna, I think flat keys are kind of efficient as well for this drumming experience, so I'm just going to set it up, but I am going to do a little bit of taper, so like the next row of keys will have an offset so they can like kind of appear closer to the keys below it. And so what does this one start at? Let's just go ahead and zero it. Whoa. Oh, because it's not in. There we go. Now it's zeroed according to the game keyboard. And 1, 2, 5. I think that's good. Get it 1, 2, 5, and then get it offset. These things are 5. 0.5 or 0.05. And so now we want it offset the other way. But now it's like a little ergonomical at least. There's only 9 keys on the middle row too, so I think it will look nicer when we delete this key. Okay, cool. So you saw how I set up a key, and how I like kind of am arranging the entire constructs of the keyboard. So I think this is a good time where I'm just going to go into a time lapse real quick and just do it and set it all up. And when I come back, I should have the full keyboard set up and typing. So let's see if that works. Okay, cool, and we are back with the keyboard fully set up with a period, and kind of we're nearing the end of this recording, the screencast. Let's just make sure to save the project anytime we do one of these big kind of huge Unity movements of things. It's always a good idea to save it because it sucks having to redo it again. And kind of the last steps, I think we need to test to make sure it's all working. The last steps are like kind of just get the keys together and then kind of make the keyboard ergonomical and add a spacebar, and I think we kind of have it. Okay, so there's a Q4 that's giving an error. Q2 also gives an error, so that's A. And then there's the 4. And then I think the other thing we could really do is like put in a trigger that makes it so we can't just go like this and like hit every key at any one time. Okay, where's like, it's around G. Ooh. Okay, so Y and, is it A? Yeah, Y and A are both need to be fixed. Besides that, it's set up all fine. Add a spacebar, put the trigger in, make the keyboard ergonomical, and I think we're pretty good. This is looking good. I'm impressed with how well it kind of came together. So QA is there, and a lot of this is just from, you have to hit return when you name stuff, so I name it and then I forget to hit return. Okay, cool. So now that that's done, let's put the copy this, and I didn't really think about it, but the whole spacebar thing is just not going to work that well with like the point light. I guess it could kind of work well. It's just going to need to be like, you need like a square point light, which I don't think we're going to be able to make, or we're not going to make that. So I think we're just going to hack around it. So I'm going to just use cube, 0.1, 0.4, 0.1. Ooh, wrong 0.4. .02. Where is he set at? It's 0.02. So I always found it fascinating how, like, cylinders and cubes don't have the same like local scale. Yeah, so let's just take the important things from the C1 script, bring it over to the cube. And those include the material hit script, the canvas with the proper lettering. We need to name the tag a key so it knows that it's a key. Copy component. Paste component as new. And drag the spotlight over and the canvas over. I guess we need to copy another cube. Just that's a little bit bigger for that side thing issue that I talked about earlier. Okay, so cube copied. Stuff on the copycat cube is going to be deleted. I think we have everything we need from here. So let's just go ahead and delete this. Fail. Whoa. So confusing. That's strange. That's why. It's because they're the exact same size. Okay. That's looking good. Let's make the text space. And so the crazy thing is we can name this a key, and then I like when I first realized this is almost ridiculous, but the naming of objects can literally just be a blank space. And so now whenever I hit this, it still works with the tag system. I'm not sure, I haven't checked if tags can actually also can be named after spaces. I mean, it wouldn't be a big deal either way because we can just go in and kind of adjust it later. So C, okay. So in this cube, let's make it 0.99, 1.05, and then apply that other wall texture to this cube. It's unchecked. Okay, cool. So now it looks like we have a space bar. And it might work, it might not. Find out. Oh yeah, it's named cube 1. Or the cube, oh my god. It's because the wrong cube is tagged cube 1. It has a key tag, which you can't have, and it needs a wall tag, so it ignores the collision entirely, or wall layer. So it's kind of nice putting on the headset. Okay, so it looks like high. Oh my god, we need a delete key too. That's something we also need. But it looks like it's working. It's not getting bigger, which is strange. I think it's because max scale shouldn't be set at max scale should be set. So if these start at 1. Should be max scale should be the current scale times 0.5. I think. You just said a 0.1, yeah. Max scale equals. Okay, max scale equals current scale times 1.5. Let's see if that works. Okay, so these still get bigger, and that just gets way bigger. That's kind of cool. The spotlight looks crappy. Okay. What can we do? Okay, so I feel like, well, first thing, let's just move this spotlight and make it wider angle. I wonder if it's gonna hit other things. And then we can also try to make it so right now it's increasing way too much. Use the range, set at that. The current scale, so it's because the X is so big. For this cube. So what happens if we flip it? Okay, so we need to undo all this stuff. And then bring that down to 0.1. Bring this up to 0.4. And then rotate it 90 degrees. Not on the x-axis, or sorry, the y-axis makes sense. Okay, so now that kind of looks weird as hell. Because now the texture is just like on the wrong side. Might just go with it. Because I think it looks kind of normal. With like, it's not the most elegant design, but it kind of like matches it in a way, and it's almost like, well, fix it later. It works right now, so might as well just, like, I could always, what I can do for the GitHub version is just redo the texture so it works. It doesn't look like it was designed by someone who can't design. Let's just center this for now. Cool. And so I think the last thing that we can do, or I mean, we need the delete key, that's for sure. So let's just copy the space. And here's an interesting exception that we can put in the collision detect to make sure the delete key works. This is the problem with space things; they're a lot harder to find. We can call this delete, and if it equals, if when we check the name for collision on the collision detect script, if the name equals delete, then instead of doing what it does before, it's going to actually subtract the last character from the string. And so, yeah, I think what we need to do to make sure that happens is we actually need to say and kind of put in in the key manager, because the key manager is where it's actually going to be subtracting the actual the key manager is where it's actually going to be subtracting the actual string. So what we need to do is in key manager we need to put another if statement. If col.gameObject.name equals delete, then it's going to do something, and then else, if it doesn't equal delete, just do the normal stuff that we had to do before. And what that thing is going to do is a good question. I think probably the simplest way to do it now is just to do like a has delete, has del bool, and so then if has del equals true, and then, well, the character number is going to go down. And this is where it gets like weird glitches, because like what happens if this is 0? What happens if you delete past a new line? If you delete a new line and then it still thinks it's a new line, it's like going to be a huge problem going forward. Just going to comment that in. It doesn't just confuse people. So the line character number is going to go down, and actually how we're going to have to do this is we're going to need to create a string called to delete stuff. Like we need to save the current text string in like a current string section, and then make the current text equal to the current string. So then we say, alright, current string equals what the text equals currently, and then we're actually going to subtract the or we're going to make the text equal back to the current string, but now subtracted from the last string. So it's current string dot substring 0 as the start. We're going to start at the start, and then we're going to end at the current string dot length -1. And so this will just take out that last letter and then go back. Cool. So we just need to add the has del okay, cool. And so I think there's some other things that we need to do, in the sense of we needed to play music. And then yeah, I think that's like kind of the, oh yeah, we needed to also do the whole material just hit equals true, and then that's it. Like we don't need to assign the name to it or say add a letter is true. Cool. Okay, so in theory this should work. One thing I'm just going to do real quick, and it may have been irking some people, is I'll save the project first. But then I'm gonna actually go in and add, like this whole time I've been working with just one sphere, and so let's add it to the other controller as well. I just copied them all twice. Okay, so now in theory we'll have two drum controllers to type on if we had not a parsing error. Okay, so it's on this. Okay, yeah, we just missed the parentheses. And if it's else, it does everything and then ends, and then also just the key thing didn't have extra parentheses. So we should be able to put on the headset now. This is like the moment of truth. Are we? Okay, we got both controllers. Bass works. See if the other controller works. Yes. Cool. What happens if the delete works? Whoa, it just deleted everything. Now I can't even type. Okay. Oh yeah, because I think it triggers has del equals true and then it doesn't turn it off as false. Like it does with has it. Okay, cool. So now, I like putting on a headset because it makes it feel official. We're almost there. Okay, so I'm gonna knock over like water balls. Hi, world. Okay, and I made a spelling mistake. Oh, R is Q. That's an interesting. Thankfully, I tested that. Okay, so R is Q, but besides that, this entire thing works. So the last two things that I think we need to do besides fixing just the R is Q thing, I wonder if there's other Qs too. It's just like a high rate of Q. I can do a search for that. Okay, there's only one Q now. Cool. So the last two things is we need to make a trigger that is over the entire game keyboard, so we can't just like type a million keys at any one time. And then just the last, like an ergonomical thing, is we need to just go in and make like the keyboard at like a 35-degree angle, so it like doesn't actually hit, and so we don't actually we have an easy time typing and an easy time speaking as well, because that's clearly a challenge for me now. Okay, so probably want it to be right there, 0.8 maybe. We want it, like ideally we want this trigger sitting just above the keyboard, and with the on trigger thing true, and then we're going to add a tag that's like, I don't want to delete that tag. It's like key lock. Okay, and so again, like really there's only one trigger in the scene, so it's like not a big deal either way. But now we just want to go in, we want to create a bool in the collision detect. It's like if the key locker is someone staying in the collision, then key locker is going to equal true. And then so if key equals false, you can do all the good stuff that we've been wanting to do for so long. And if not, then we can't do it. I guess we can just do on trigger stay, so if it's in the trigger, and then on trigger exit, it's going to actually turn it back to false. Just saving our ass if we want to do more trigger stuff later on. Is it keylogger? Keylog. Okay. And let's also attach this to the game object script so we don't just lose it. Should probably close some of these brackets. Okay, the gamer keyboard, key lock, no, key lock. Okay, and this is, I think, the martini line. We are now, don't quote me on that, but I think that was the last thing we have to do script wise. If I could write this stuff correct. I don't know what I did wrong. Oh, I know. I didn't include a void which says we don't need a return because this is a normal. This is normal. Okay. So in theory, when we're in it and typing, I can't type until I lift this out. And if this is in, I can type with the other one. But I can't type if it's in, and I can't like hit a million keys at once. Looks like I can a little bit, but I think that's pretty ideal. Huh? It's kind of like I can hit a lot of keys right there. Okay, I guess I can tap these keys really fast. I think that's effectively good. Let's try typing something. Oh, let's make it ergonomical. And then I think we're good. Okay, so now we have the gamer keyboard. And let's make it a 35-degree angle. And let's also put this canvas so it's attached so we can just move it all as one. It's weird how when you drag anything in, it just expands fully again. Yeah, okay. So now, in theory, I could drag it all around. Back up, unplug, and hi world. This is, it's actually kind of fun. You know, I feel like during I/O they really hyped it up really hard, like really high, like this is like the most amazing input system ever, and it's cool. But I mean, it works. It's pretty fun. Like I do think I want to incorporate this into like some of the UI for some of the VR games that I do. But it's more of like a novelty, like very material way to type, more so than like this is like the end all. Like I think pointers win in terms of familiarity. But the other idea is like now that this is built, like I can kind of test it out in like the Daydream controller environment or just Google Cardboard or Tango environment, and then also like kind of test it out. So like what is the word per minute versus like a pointer system? So I don't know. It's interesting. Like it's cool. It's certainly the VR stuff is exciting. That's for sure. So cool. Well, yeah, awesome. Thank you. Thanks for everything. This is kind of the first of what I hope to be many Daydream streams. Like kind of the idea is that this Daydream Labs, like they have, like what they did really well is kind of talk about UX amazingly, like, and you know, build these like kind of obvious example projects that have like real value to the VR community. And I think they did a great job of selecting the projects and selecting some really cool projects that are a great mix of like simplicity but usefulness, but then also like still kind of fun and rooted in like these intuitive VR experiences. So one thing that I'm looking forward to do is to actually build them, because they made all the examples, or they talked all about them, but then they're like, oh sorry, you can't even play the games, let alone see the code of how we did it. So, you know, the opportunity is here for developers to talk about it and post some open source projects. So I'm psyched. Thank you everyone for watching.